lesson here because it's going to pop up. So it will be very, very helpful to have a scientific calculator. Now, you have a choice. You can either get a simple scientific calculator like this. What makes it a scientific calculator is somewhere on it you'll see SIN, COS, and TAN. It's actually a trigonometry idea, and we will actually be studying trig in here. So if you have a calculator that does not have that, it's not as useful, harder to use. You could also choose to get one of these guys, which is a graphing calculator. A little more expensive, obviously, instead of like, I don't know, 20 bucks. These are like 100. But these will actually be sufficient all the way through everything you do for the rest of your life. Any calculus class, anything, this is going to have everything on it that you need. They are expensive. They're, like I said, about 100 bucks, but I've been very successful finding them on Craigslist or on Facebook Marketplace for 30 or 40 bucks because somebody has it and they're like, I haven't used this in a couple of years. Somebody want to buy this thing? And you're like, yep, pick me. And I've purchased a number of, that's how I buy them for my kids. Every time I get that one of my children gets to the age that I have 3 kids, and every time they hit that age, I just go on Marketplace or on Craigslist and I find one and arrange a meet, and I get it for 30, 35 bucks, and it's a $100 calculator, and it's a win. So it would be helpful to get one. Okay, any other questions? Because I always want to do that, because there are things in there, and I hear people sometimes go, man, that was really, really hard. Well, if it was, let's talk about it, because it really shouldn't be particularly difficult, but if there's anything that kind of hangs you up. So you guys do need to submit those 2 assignments through Google Classroom. I'm going to be a little bit patient. I'll give you a couple of days because I know that's hard for some people. Did anybody try to take pictures and upload pictures? Like actually write on paper and upload pictures? Or did you had the 2 assignments were, you guys were actually assigned. I can go back into, let's go ahead and do a quick share screen so you can kind of see what I would have. But this is your class right here. Let's go to you, your Advanced Math 2. In your classwork, what you guys were already assigned was this stuff right here. You were assigned to do 111, which is both this set and this set. And so you were supposed to do that work and then upload pictures of your work or type directly on the document and do that. If you haven't finished it, notice we have 10 of you have it turned in and 15 of you don't. I'm not worried about that. You'll get a couple of days. I'll just make sure that we get it in. I would like to have it in as soon as possible because I'd like to have your grades up to date, okay? So if you need help on getting that stuff submitted, feel free to ask and I will be more than happy to go over that with you, okay? So no questions on homework? Oh, the capital letters. Okay, let's do that. Let's take a look at it. Was that in, that was in the first one, wasn't it? Okay, let's take a look at it. So when you get to the capital letters and you think about it, here we go. So can everybody see that okay? So notice they did it with capital letters. So what we're trying to find out is, does it have reflectional symmetry? So like if you look at A, is there a place where you could draw a line where if you flipped it across the line, it looks identical? Right straight down the middle, if you flipped it over, it would do that. What other one would, well, this one also works. See D? It has reflectional symmetry too. Where would that line be? Horizontal line, perfect. Would H have it? Yeah, in fact, H kind of has 2 of them. You could either go through the middle, vertically or horizontally. So you're finding those that do that. Now, rotational symmetry is kind of interesting. Take the letter S, for example. What would happen if you took the S and you flipped it over 180 degrees? Would it be the same? How about the letter T? All of a sudden, instead of being up, it would be sitting down, so it would fail that. So what does T have? It has reflectional, but it does not have rotational. How about X? It has reflectional, but it also has rotational. So it would go here in this middle section. So can somebody tell me one that would fit over here in rotation only? So it has rotational symmetry, but it fails the other tests. I can think of two. Yeah. Z is a good one. And Z and N, good. Z, N, and I think S. All of those you could flip them around and they would actually satisfy. So where would F go? Yeah, F goes like off to the side somewhere. It's kind of banished. It doesn't fit in anywhere, does it? Who else doesn't fit in anywhere? L doesn't. J, Q, P, R, a lot of them really. How about V? P has reflectional. Yeah, we have some of those. Okay, does that help a little bit? Just thinking about how you would actually do that? Okay, any other questions? Yes. Sure, the Google Classroom code, that would be important because Sabian might not know that either, but your classroom code is right here. It is NRN VV5S. And remember that when you signed up for your ebook, you guys got your ebook last time. Sabian, you did not, but I sent you an email already that showed you where to get it and what the code was to have access to your ebook, okay? So in that email, it's an SRT. There's 5 letters, some of them are SR and T, and it's in that email that I sent you. So we good? Homework questions? Did I get that email? I did not send it to you. Oh, yeah, because you're a new student. Okay. When I get everybody started on something in just a few moments, I will come and give it to you, okay? All right, so here's what's going to go down. So for me, what I like to do, this is sort of my, my way of doing things. Your class is supposed to be kind of interactive, group work based. You kind of figure things out. You kind of go through that process. But I really do like to interact with you as well instead of just watching you work. So you'll notice that I ask a lot of questions and ask for feedback. It's much more interesting than just me sitting there, talking and you sitting there passively. I'd really like to be energetic. I don't ever want to be one of those super, super boring teachers that just sits and drones on. So if I am, you could be nice and say, move it along, Penner, you're getting kind of long there. I won't be too offended, okay? So anyway, what's gonna happen is today, I actually wanted you to take a little teeny bit of notes. But when I say teeny, I mean it's gonna be short, okay? Because I think some of you guys really haven't done any math in, what, 5 months? That is insane. I have never done 5 months without doing math. I still haven't done 5 months without doing math. I was doing math while you guys weren't. But anyway, it's all good. Your life is just not good when there's no math in it. So we're going to get back into the scoop here. And I want to talk about solving equations. And I think you guys are probably pretty good at most of them. Now, I have a suggestion for you. Not a requirement. This is not a requirement, but it's a suggestion. I would love it if you can get one of those. And honestly, if you're like, I'd really like one, but you know what, they're 50 cents at Walmart and I'm just cash strapped. I just don't think I can come up with that 50 cents. And you're telling me that where you have a $4 Red Bull in your hand. It happens. I see that all the time. Just way too much money. Anyway, if you could get one of these, if you can't, I'll give you one. I will give you the 50-cent piece of paper. But the reason I like these is how much room do they take up, like on a shelf? They're non-obtrusive, aren't they? So if you take your notes in your math classes in this, how much would an entire high school career of math take up on your bookshelf? I'm not kidding when I say it's that much space. And then when you go to college, you would have all your notes from high school. And so when they're asking you a question, you're like, yeah, I used to know how to do that. And I can't remember. Would you be able to find it? And then you just have a record. Now, some of you are like, yeah, but I like the 3-ring binder. Does this take up room? You also know that not only does it take up room, the papers rip, don't they? And the binder falls apart. And so when I was in your boat, I'll admit it, every year at the end of the year, you know what I did with my binders? Yeah, my buddies and I, we all had a bonfire. We burned those suckers. We're like, let's get those things out of here. To celebrate the end of the tyranny. I get it, but these are just really unobtrusive. And then later on, you're like, that was actually be really helpful if I had. So when I put these things in, please don't rip pages out of it and all that stuff. I just put in things that are really important. So if it's just like a quick example, I usually don't do it. It's just the stuff that's really important. So I'd love to see you get one of those. And if you can't get there to get one, just let me know. I have a few that I'll give you. So anyway, in your notes, I'd love to talk about some of these. And there's a specific kind of problem that we actually did some solving equations the other day when you were here. And it's specifically solving rational equations is what I'm concerned with. And there's a variety of ways to solve this problem. But the reason I'm going over it is not because of what it in and of itself is. What I'm actually really concerned with is how this is going to relate to something we are going to do in here later on. Have you guys ever seen a scale model of something? Like where you see an airplane and then somebody made a little airplane and it looks like the same as the original and all that kind of stuff? I know you have. Well, mathematically, when you go and try to solve things about it, this is what you have to do. You have to set up a little equation that looks like this. One set of ratios is equal to another. And we're going to do that in here. And so if you know how to solve this, then you'll be able to take those shapes and actually do okay. So does anybody have any suggestion on how you would actually solve a little equation like this that has one fraction equal to another? Yeah. Okay, very nice. So, option one. I'm going to put that over here. Number one, multiply by 21, right? So now if we multiplied both sides by 21, the benefit of that is 7 goes into 21 how many times? So we could cancel the 7 with the 21 and leave 3. The 3 would go into 21. And now what we're going to do is we're simply going to use the distributive property because 3 times 5x would be 15x. And 3 times negative 2. That's the part that a lot of people forget. You don't just, it's not 15x minus 2, it's 15x minus 6. Because 3 times 2 is 6 is negative 14. Everybody goes, so far, everybody okay? Now what? We got to add 6, don't we? Yeah, let's add 6 to both sides. 15x is, well, if I add 6 to both sides, I got negative 8. And then the last step would be to divide both sides by 15, right? And at this moment in time, many of you would look at this problem and say, okay, you made a mistake, Penner, because the answer can't be that ugly. Is negative 8/15 an okay answer in mathematics? It is going to be a very common looking answer to have a fraction in your final result. You guys okay? Now, I'm going to go over here and call this number 2 because there's another way you could have done that. Let's see if somebody has another way that your teacher or somebody taught you. Yes, in the back. That's my favorite way. If you have one fraction equal to another fraction, simply cross multiply. So guys, what is 3 times 5x minus 2? And then you go this way and you get negative 14 and you just landed in that zone right there, didn't we? Really quick, didn't we? So I'm not going to finish solving that problem because we already did it. So can you guys do this for me? Can you do this one? I don't care which version you use, whichever one feels the most comfortable. I personally just like cross multiplying. It's just nice and slick. So you're going to do 2 minus 7x over 4 is equal to 8x plus 1 over 3. these won't have nice answers because I don't care what the answer is. I care about the process that you can execute that. It's Ethan, right? You're Ethan, right, Ruben? I'm going to be trying really, really hard to get to your names, but really hard with the mask on. It's super hard. So I'm going to do my best. So I hate to say, hey, you. Dang, but I normally have a list up, but it's because I'm sharing my screens, I can't have my list up because then my list would be instead of the screen. So yeah, I'm figuring this out. Fun time. Caitlin, Greg, right? Did I do that right? Did you cross multiply this direction? What'd you get? Oh, you're not finished. Just that one step is what I'm thinking. Can somebody tell me what the first step would be when I cross multiply this direction? I'd like somebody that hasn't answered yet. Somebody willing to answer when you multiply the 3 up. Yes, thank you. 6 minus 21x it is. That's beautiful, right? Okay. Let's go the other direction. Someone else that has not answered. Let's see if we can move around. Yes, in the back. 32x plus 4. That's perfect. Now, does x always have to go to the left side of a problem? Heck no. Go which one is easy. So do I want to move the 32x's to the left or should I move the 21x's to the right? Why? Ding, ding, ding. Why deal with making things negative when we're probably going to make a mistake? You know what I see in my calculus class all the time? People do calculus great and then they add poorly. They do all this really sophisticated math and then they blow it. Now, I do want to be clear on something because there's so many steps to math. Can some of you guys go from this step to that step without ever writing the plus 21x underneath? Can you just visualize that? Feel free to do that if you don't need to, okay? This step right here, it's really more as a help, and if it helps you, do it. If it is like, oh, I don't need that, so what's my next step? Ooh, careful. Back up a little bit. You almost said that right. Yeah, let's subtract 4 from both sides. Now, in this case, notice I didn't actually write minus 4, but can you tell that's what I did? So when you guys are doing that, I have to leave that up to you, and please understand, I'm not mocking anybody for writing minus 4. If that's what works better for you, and you're more accurate, you know you, and so do that, okay? And so the last step is we're going to divide both sides by, now this is a bummer because a lot of times people have this upside down. So when I divide both sides by 53, I will show that step. 53 over 53 is 1. So x is 2 over 53. That is a terrible looking answer, isn't it? But that's my answer. It is what it is. It's all good. I don't mind it. All right, now, I've got 2 more problems. Number 3. Now, I was asking what Ethan's name is because he was the one that brought this one up. Now, what set this problem apart from the previous example is this is not 1 fraction equal to 1 fraction. It's not. It's not A over B equals C over D. It's totally different. So this is the place where I would go for sure with what Ethan said. So what should we do? Step 1 right here to make our life better. Yeah. multiply every single piece by 7. And now the critical piece of that statement is that you're not multiplying some of it by 7, you're multiplying everything. This is the distributive property, everybody. So you're going to hit every single piece with a 7. So I've got 35 up front. I'm skipping. I'm going to write 21x there. I'm going to write 7 right there. I'm worried about this one in the middle. What happens in the middle? The 7s cancel, and I got negative 2x. And I took a hard problem, and I turned it into an easy. No big deal. Okay. Moving along, someone different. Where would you go from here? Someone that has not responded. I'm sorry, I'm being so mean. Anybody have an idea that has not responded yet? Where would you go from here on down? I haven't heard from Eden. I haven't heard from some of the others. I'm trying. What would you do? Oh, I know. What would you do? Let's go ahead. Do you want to move the 21 or the 2x's? The 2x. So since this is negative, let's add to both sides. Now what? What would you do? Could we divide by 23 right now? And the answer is actually we could do that, but there's something that I think I would like to do first. Yeah. Let's subtract 7 from both sides. We're going to try to get that x thing all by itself. So when I subtracted 7, I got 28. And then the last step, now let's go ahead and divide by that 23 because it's going to be easier. And we got, 28 over 23 because we divided both sides. And I told you I had 2. This is the last one. And I'm going to be nice to you. And what is no longer in my problem? This one doesn't have any fractions in it. It's just a straight can you handle the distributive property story. Yeah, sorry. My penmanship is not good. So I admit that. So, Sabian, can you hear me okay? Can you turn off your mute for a moment and just let me know if I can hear you?
Hello?
Hi, just making sure you can hear me. Can you see everything okay?
Yeah.
Okay, Sabian, what's the first thing you would do in that problem?
Use distributive property on the 4 parentheses.
Okay, so what would you get then?
20x and negative 32.
Okay, and we've got all this. Now, I left some pluses and minuses off of that for a second, just because I want to make sure. So, am I distributing a 4 or am I distributing a negative 4? And that it almost sounds like I've planted that, but yeah, I'm definitely distributing the 4 plus the negative that's stuck to it, okay? So a negative 4 times a positive, that would be this, right? And what about the 32 then? That's going to be a positive on that 32. So, you know, it almost feels like I rigged it to always move the other direction. Most people like X to be on the left side, and I wasn't trying to be ornery by making them all. I just sort of randomly, I just made up some questions to show the concept. Which way would you guys, oh, I wrote 2, didn't I? Let's fix that. That was supposed to be 20x, wasn't it? So, all right, where should we go? What should we do now? We're getting close. We want to group those things. So added 20x to both sides. So when you add 20x, you get 24x's. Then, of course, now that we have all the x's together, what are we going to do? Subtract that 9. That's going to give me 31. Now, again, notice I'm kind of implying work that's there, and if you need it, go ahead. And then the last step, what's my final answer? Wait, what? What was it?
X equals 1 and 1.
Okay, yeah. How did I get 40? Oh, because I had 8 here and 32 here, and I put those two things together. Oh, I didn't even say it. I should have told you I was going to combine those like terms, right? Those values that are together. So we're going to divide by 24. So I think we have an issue. So this would be, when we divide by 24, the answer then, x would be by itself is 31 over 24. And so you said that went in one time with some leftovers, right? How many leftovers?
6. No, 7.
7. Oh, okay. Yeah, 1 and 7 24ths. Now, in your previous school, your teacher may have told you never leave the big number on top of the fraction. You ever heard that before? Leave it. It's the reason why is a developmental thing. When you're a little kid, if I told my little nephew that he could have a cookie and a half, because maybe there was some there and there were some halves in there. Do you think, now he's 2 years old, do you think he could understand a cookie and a half? He'd go up and he'd find the cookie and he'd be like, sweet. He'd want the second cookie full, but he'd be okay with the half and enjoy it. But if I said, hey, Dean, what's his name? Dean, go get 3 halves of a cookie. What? He just go grab 3 cookies. Developmentally, it doesn't make sense, but we should know. And it turns out the reason we like this is anytime you add 2 fractions together, you don't go 1 and 7 24ths. You have to go back to 31 24ths and then go through it. If you want to multiply it, you have to go back to the improper fraction and go for it. So for my class, I like it that way, okay? So you can actually just bail out and leave it the way it is, but should you reduce? If it was 8/10, then go down to 4/5. That's actually legit. So what you guys are going to do right now, and let's go ahead and get over here to the Google Classroom. What you guys are going to do is you are going to go to 1.2.1 assignment numbers. So you see these 2 assignments right here? I'd like you to go to this one right here. And what you'll notice is when you go into this assignment, which is 25 through 29, as soon as it opens, you're going to see that you're going to do a little bit of work on, oh goodness, come on. Do you notice anything about number 26? Looks kind of similar to the little lesson that I went through, right? I wanted to make sure you had a little experience with that. So what I'd like you to do is do problems 25 through 29 for maybe 10, 15 minutes. We'll talk about how you did and how those answers worked. I don't know if you guys have ever had experience with diamond problems before. So if you don't have diamond problem experience, you're going to notice right here, see the X and the Y? The things that go on the sides, notice their product goes on the top and the sum goes in the bottom. So if there's a 6 and a negative 11, what would go on top? Negative 66, and their sum would go down here, and that would therefore be negative 5. That seems silly, but it's going to be a really important skill for something else that we're going to do at a later date, okay? So I'm going to give you a few minutes. Sabian, hopefully you have access to that textbook. If not, it doesn't matter because you have it in Google Classroom, and you can look at 25 through 29 on 121. You guys can write on paper and upload a photograph of your work if you'd like to, or you can type, okay? For a lot of you guys, in fact, you guys here in class, I'd almost rather you just take out a piece of paper and write it down, get your name on it, do a good job writing it, and I'll have you physically turn that in. Okay? I do need some stuff submitted electronically, but we already did that on the first 2 assignments, okay? So if you guys, I would actually almost rather you just do it on paper. What's that? I think those blue flags had something to do with what happened when we imported it out of a different file into this. I think it's a Google Doc, like, I'm not sure if something translated right, I guess, I don't know. Good question. For what? It could be. Yeah, because there are review previews and then there's the individual practice kind of a stuff. All right. So, Sabian, we're just going to work for a little bit. I'm going to pause the, okay, so for the next portion of our lesson today, what we wanted to do is take a look at the next lesson, which is 1.2.3. And what we wanted to do is visualize that there was these cool rugs, and you could get small ones, and bigger, and bigger, and bigger, and bigger, but they always follow this very, very simple pattern. So what I'm going to do is show you a really quick pattern and then discuss how we would do the mathematics on that. So you're going to notice this thing right here is I have a rug like this. It looks like a T, but I could make it larger and larger and larger. And honestly, these should get really, really big, but I drew them smaller so that they would fit on my paper. And so you notice right here, I have these 5 little squares together, but over here I also have 5 squares that are just getting bigger. And here I have 5 squares. So 5 squares that are 1 by 1, 5 that are 2 by 2, 5 that are 3 by 3, and it keeps getting bigger. So when we want to look at the perimeter of this, one of the things that you would notice is if you were to walk around this, you would need 3 steps to walk around the first leaf, 3 again, 3 again, and 3 again, which was a total of 12. Over here, each leaf was 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I had 6, 4 leaves for a total of 24, and that's 36. And we had a discussion as a class, and I'm sorry I forgot to video it, that's why I'm doing this now. But we discussed how when you get out to any step in, it could be the 10th step or the 20th step, whatever step it is, you're always getting 12 times that number because you can kind of see the pattern right here. Now, in that same way, if we wanted to talk about the area of the figure, you notice that this one had exactly 5 pieces. This one over here also had 5 pieces, but each of those pieces had 4 of them in it, so 5 times 4. This one also has 5, alternating between shaded and not, and those each had 9, so 5 times 9 is right here. And so what we kind of figured out is every single time, whatever the figure number is, the first one was 1, the second one was 2, the third one was 3, we always have a perfect square, and there's always exactly 5 of those squares, so we could predict how many squares would make it up, and we could also predict how many squares, how much it would take to make a fringe around it, or something that we would talk about the perimeter. So for those of you guys working at home asynchronously, those of you that are doing this on your own, what I want you to do is go into 1.2.3 and do the assignment on 1.2.3, and I would like you to do this design right here and see if you could answer the questions that are there. So hopefully that's going to work. I'll leave that up for a moment, but remember, you can always pause the video. And I'm going to go ahead and hit stop share. And that is kind of the end of the lesson today, although we will discuss that at a later part of the period. So I'm going to hit pause now, and we'll probably talk in a little bit after students have worked on it. Okay. Okay. So, hey, we only have 5 minutes left, so I want to double check something. What shape did you guys get every single time you did the perimeter? You all had different shapes. So what would you describe the shape of the graph? It was a line. It seemed to grow as a line, didn't it? Did you guys get to the area? The area did not grow as a line. Did you guys figure out what it did? It was kind of a curve. It's actually known as a parabola. So it's kind of cool that the perimeter grows like a line. Now, are you guys familiar with discrete versus continuous? Yeah, these are all what are called discrete because you don't have the 1.5 figure. You either have the first figure or the second one, right? So remember this one, a lot of people are tempted to draw that line. There shouldn't be a drawn line or a drawn curve. You should just see those distinct little dots, and that's okay. So does everybody know what your homework is? So you're going to be doing those 2 assignments, 25 through 29 and 31 through 33. If you have some work on paper, you may absolutely just on the Google Doc just write answers below, and you can just take a picture and post your work's picture at the very bottom of your document. Or if it works for you, you can take little snapshots and put it where you want it to be in context. I'm going to be very, very flexible on that. Now for you guys, what I'm going to do, this is just kind of a new thing we're experimenting because I'm not supposed to touch your work a lot. I'm also not supposed to be right up in your face that much either. So what I'm going to have you guys do when you come in tomorrow, you're going to take out your stuff and you're going to write down on something how much of the first assignment you did and how much of the second assignment you did. With me? And I'm going to walk around and I'm going to write down what you told me. And if you said, Mr. Penner, I did all of it. I did all 6 problems, 6 out of 6. I'm going to write that down in my book, and I will give you credit for what you told me. But I have a random number generator, and I'm going to check about 4 of you. And if you lied to me, you get a 0 on the assignment. So as long as you're honest and said, yeah, I did 4 out of 5, then that's the score I'm going to give you. But if I check you and you did 1 of them, that means you lied and you get a 0 on it. Yes? How would I check you? Show me your work. So for some of you, I'll just say, what did you give yourself? And I'm just going to write it down. What did you give yourself? Oh, actually, you're one of the ones I'm going to check. Prove it. Show me what you did. Did you actually do what you said you did? And that way, I don't have to touch things as much, and you get your grades quicker. And as long as we're honest, we're good because your homework doesn't have to be perfect. Guys, no, homework is about practicing and figuring things out. If you make mistakes, it's all good. I don't mind if you make errors. So please let me know if you have questions. I am available. You can email me. You can stop by. Yeah. You probably want to keep that, especially for those of you that are not done